Hey guys, and welcome back to your AP Chemistry videos. Sorry that it took so long to get this one uploaded. We had a person at our house working on the siding, and he decided to slice our internet and our TV line in half. So we have not had TV for a day and a half or internet. Just got it back up and running, so I'm making this video, and then hopefully you guys will still see that it's there and watch it before Monday. Anyways, let's get going here with our subatomic particles. This should be a pretty quick video, and again, this should all be a review from your class a couple years ago when you first took chemistry. Subatomic particles. We know that there are protons. They are inside the nucleus, and the protons determines the element that we have. If we have one proton, we have the element hydrogen. If we change that number of protons, then we change what element we have. The charge is +1, resides in the nucleus, and it has a mass of 1 AMU. That AMU there, whoops, let me go back and get my pen here. Okay, let's go back. This mass of 1 AMU is actually stands for atomic mass unit, and that's something we haven't talked about yet. So anytime you hear this AMU, atomic mass unit, it's a unit that we developed to make it easier to work with because nobody wants to work with 1.673 times 10 to the negative 27th kilograms. It's an incredibly small number. It's too hard to work with. So we decided, oh, that number is going to be 1 AMU. If we take a look at our neutrons, we know they are also in the nucleus. They also have no charge. And just like our protons, they have a mass of 1 AMU as well. So that's one atomic mass unit. There's a very, very slight difference in mass if you look at the kilograms weight, but it's not significant. And for us, we're just going to know that they both have the exact same mass. The last one that we need to talk about is our electron. It has a negative charge. If the proton is 1 plus, our electron is 1 minus, so they cancel each other out 1 to 1. And they are constantly moving around the nucleus, so they are outside of it, the only particle that is outside of the nucleus. It has a mass of 10 to the negative 31st kilograms, and for our purposes, again, this is going to have no mass. We're not going to have to remember this number. We will rarely ever use this number. So just know that our electrons really don't play a factor into the mass of an atom. However, they are responsible for something very important. They determine how reactive an element is. So based on the location of an element on the periodic table, you'll know how many electrons it has, and you'll know the reactivity of that element as well. Just like our protons determine what element we have, then the electrons determine how it reacts with other elements. You combine all of these together, and we get our subatomic particles that make our atom. If we look over here at our two illustrations, we talked about this on Friday, but this would be our Bohr model of the atom, which we're going to use both of these. And down here is our modern atomic model. The difference between these two is that in Bohr's model, we have defined orbits where the electrons must stay in these defined orbits as they rotate or orbit the nucleus. And they don't really deviate from these orbits. They tend to stay in those orbits and just keep going around the nucleus. Whereas in our modern atomic model, we've got what we call the electron cloud. And basically, electrons are just somewhere in this cloud. And the darker the cloud is, the higher the probability of finding an electron is. Usually it's darker closer to the nucleus because they're attracted to the positive pull of the nucleus. And as you get further away, it's harder and harder to find an electron because it's harder to escape that positive pull. Isotopes. This will be the second to last thing for this video, so we're almost done. Isotopes, they are atoms with the same number of protons but different numbers of neutrons. Now, this is really important for explaining the mass numbers on the periodic table, and we'll get there in just a second. Almost all elements in nature are going to be a mixture of different isotopes. If we take a look over here at this illustration, this is what we call our isotopic notation, right? And if we look there, X is going to be our element symbol. So we're going to take a look at carbon. So we know that carbon has 3 different isotopes in nature. We have carbon-12, we have carbon-13, and we have carbon-14. Those are the 3 different isotopes, and the number on the top, represented as A in our general equation over here, that's our mass number. So we have 3 different weights for our carbons in nature, and the atomic number has to stay the same. So despite having 3 different weights, we do have the same atomic number for every carbon because that's our number of protons. And if we changed our atomic number, then we would change what element we would have, and it wouldn't be an isotope of carbon anymore. So how do we have a different mass for each one of these if our protons are the same? Well, we know electrons don't weigh anything, so that means we need to add 1 neutron to each one of these isotopes. So this one would have 6 neutrons and 6 protons. This would be 6 and 7, and this would be 6 protons and 8 neutrons. This here would be an isotope chart, so based on the information given to you, you have to fill out the blanks, which is really pretty simple. If we look over here, we have our atomic number. I just said that that is the same as our number of protons. So if we have 2 of these guys, we can fill out that we have 2 protons as well. Now, our mass number consists of protons plus neutrons. So that means these 2 must add up to give us our mass number. So what do we need to add up to 2 to get 4? We need to add 2 and 2 together. And so we have 2 neutrons, 2 protons, gives us a mass number of 4. Number of electrons for this particular chart is going to always be the same as protons because we have no charge on our helium, or we have no charge on our magnesium, or we have no charge on our zinc. So that means that our protons and our electrons must cancel each other out equally. So if we have 2 of the positive charges, we need 2 of the negative charges as well. Likewise, if we go down to the next box with magnesium, if we have 12 protons, because of its atomic number, that means our electrons must also cancel out equally and have 12 of those as well. The last thing we have to fill out is our mass number, which is protons plus neutrons, and that gives us 24. I'll leave this last box for you to fill in if you want. Otherwise, there will be a homework problem for you in the book at the end of this video. Last thing we need to talk about, which is kind of not really related to what we just went through, but I want to make sure I mention it for you guys to help you start memorizing your ions here. If we look at our periodic table, we will notice that group 1 all has a charge of +1. So everything in this group here has a charge of +1. Everything in the next column over has a charge of +2. We are going to skip our transition metals for now because those get weird. They have variable charges. Sometimes it's +1, +2, +3, even sometimes as crazy as +6 or +7. So we're not going to worry about these quite yet. But if we continue on over to here, we notice that we have a +3 charge for these 2 elements. Right? Then we switch. Once we get here, so this is group 1, 2, then we've got group 3 and 4. So in group 4, we don't really worry about it. It could be plus or minus 4. That will be determined based on the problem we are given, so we don't have to worry about this column here. Then we have group 5, 6, 7, and 8. Group 5 is going to have a charge of -3, then 6, -2, 7, -1, and when we get to 8, we have a charge of 0. So there's no charge on any of these elements, or any of these elements' ions. They don't have ions. It's as simple as +1, +2, +3, -3, -2, -1, and you skip that one there in the middle. We'll talk about this more in class. We're going to go over our ions more in class. But for now, I want to give you a couple other homework problems, which should really not take you too long. This will be at the end of your book in chapter 2. It's just going to be number 57. So if I pull up this here really quick. So chapter 2, number 57, number 60, and number 68. Those are the only 3 problems that are homework as well as watching this video. So make sure you have these done when you come to class, and then we will continue on Monday. Hope you guys enjoy your weekend, and see you Monday.